So now that we have a sample statistic and some population, trying to estimate a population parameter, we want to know how well we can estimate. So one thing we need to find out is our sample statistic an unbiased estimator of the population parameter? It turns out that a sample statistic is an unbiased estimator. In other words, it gives an accurate estimate of a population parameter if the mean of the sampling distribution of the sample statistic has the same value as the population parameter. In other words, the distribution of the sample statistic is centered at the true population parameter. And we're going to look at an example of that in just a minute. Now, something to note is when we do a simulation, simulations do not ever capture every possible sample of the same size from the population. So we usually find that the mean of our simulated sampling distribution is just very close to the population parameter, but not exactly equal. But theoretically, it would be exactly equal. So in order for us to have a really good estimator or a point estimate for a population parameter, first of all, the estimator must be unbiased. It must be in the center must be correct. And it has the least amount of variation, because obviously we don't want to have a lot of error in our estimate. So here's, this is just a little illustration of what we mean by those two characteristics. If we were trying to hit the target, this target would be the population parameter, the middle of the target. I'm trying to hit that target with my estimate. Well, this estimate is nice that it doesn't have very much variability, but we totally missed the target. So this estimate would have a high bias, okay? It would not be unbiased, but it does have low variability. I guess that's nice if somehow I could figure out a way to change the statistics so that I moved it into the center. At least we would know the variability is in good shape. Here we hit the target as far as the center of all my guesses are close to what I really want to get. So this has this is unbiased, but it has a lot of variation. So in other words, it's centered around the right place, but we're going to be off by quite a lot many of the times. This one's just bad. It's not centered at the right place, and there's a lot of variability. And this is very good. This is exactly what I'm looking for. I want to look for an estimate that hits the target, clusters close to the target value every time with little variability. Now, I do want to emphasize that when we make statistical graphs, they do not look like a target. This is just a kind of a word picture, an example of what we're talking about. But we're talking about graphs and centers of graphs and so forth, like something that would look like a normal model. So we did a class activity where we had everybody put their height up on a graph. Okay, so here's our heights. We had everybody, the lowest height was 61 inches, the highest height was 75 inches, and everybody put a little magnet, a little colored magnet at their height. And we found out the mean of all of our class heights was 68.9 inches, and the range, 75 minus 61, would be 14 inches. Then we want to investigate the sampling distribution of two sample statistics. We wanted to find the sampling distribution of the mean and the sampling distribution of the range of the heights. So what I had everybody do is enter all of the class heights into a list and randomly sample 4 of them. And so they had a sample of 4 people in the class, 4 different heights in the class. Now, when I say different, 4 different people, they might have had same heights because some people did have the same heights, but they had 4 heights out of this group of heights. And then I had everybody find the mean and the range of their sample heights. So we wanted to find the sample mean. Okay, so this would be x1 plus x2 plus x3 plus x4, the 4 heights divided by 4, and the sample range, which would be x high minus x low, the highest height minus the lowest height. Okay, so whatever the highest minus the lowest was. And then I had them do 2 more graphs. I had them first put all of their sample means on a graph and then all of their sample ranges on the graph. And we wanted to know were these unbiased estimators of the population statistic that we were trying to estimate. So is the sample mean, x bar, the mean of the 4 sample heights they got, an unbiased estimator of the population mean? Well, we knew the population mean is about 68.9. So what we're looking for is are all of our sample means clustered around the population mean of about 69, and that looked very reasonable. Now realize we only did, I think we did 2 samples per person because we didn't have enough data to really see what we were looking to see a good distribution. But if we kept going and going, we would see that this would actually be even more and more obvious that the sample means cluster around the true population mean. So we said yes, because the mean of the sample means about 69 looks like it is about equal to the population mean. So that looked really reasonable. Now notice this is called a sampling distribution because unlike the first graph we made where each magnet represented the height of one individual person in the class, now each magnet represents the mean of 4 heights randomly sampled from the class. So each one of these is a sample mean, an x bar representing the mean of 4 heights. Then we had everybody put their sample ranges on. So I'm going to kind of extend up here so I can see this a little better. So is the sample range an unbiased estimator of the population range? So you can see here all of our sample ranges. The center of our sample ranges looks like it's kind of around 8 or 9 maybe. And so we said no. The distribution of sample ranges is centered at about 9 inches and the population range is 14 inches. So the sample range is not an unbiased estimator of the population range. It is not centered at the true population range. In fact, it's not even possible to get any sample range greater than 14. That would only happen if you happen to pick the highest height and the lowest height in your sample. Most times you're not going to get both the highest and the lowest value in your sample, so your range will be less than 14. So the sample range is going to consistently underestimate the population range, which is a form of bias. It is not an unbiased estimator.